Hey, what's up, guys? This is your video for your assignment for Wednesday, February 24th. The assignment is called Nature is Always Changing, but the Number of Atoms Isn't. Okay. This week, we're kind of just trying to bring everything together. Okay. We started with chemical reactions. We did some chemical reactions in class. We mixed chemicals together. We talked about how it's like if you make a cake, the ingredients that you put in are going to come out the other side, right? They look different, but they're still the same thing, okay? And that's regardless of what it is. If we're talking about putting baking soda in vinegar, or if we're talking about photosynthesis in plants, or if we're talking about like your bike is rusting outside in your yard after it rains or something, right? All of those are chemical reactions. And what's super important for us to be able to remember and to be able to explain is that when we have these chemical reactions, right, all of these atoms that we can't see, these tiny building blocks of the world, right? Like we said, if the world was made out of Legos, like they're each individual Lego, right? Like I'm made of cells, but even my cells are made of atoms. My coffee cup's made of atoms. Everything's made of atoms, right? This air, when I breathe, there's carbon dioxide and stuff in that. Those are all atoms, right? So when we're talking about these chemical reactions, the number of atoms isn't changing. And what I mean by that is the atoms that go in are the same number of atoms that come out. Like nothing gets created, nothing gets destroyed. So when I breathe in that oxygen, right? I breathe out, I'm breathing out CO2. When we learned about cellular respiration and photosynthesis, those atoms are recombining, they're making different things, but they're all still accounted for. And what I mean is like in this equation on the screen right here, right? We have carbon plus sulfur equals carbon sulfide, okay? And what we're saying is like this is 1C, right? So that is one atom of carbon. This is 1S. This is one atom of sulfur. This is 1CS2. This is one molecule of CS2. But if we're looking at the individual atoms, C is an atom, and then each S is an atom too, right? So that's 1, 2, 3 atoms. So if we're looking at this, 1 plus 1 is 2. 2 does not equal 3, right? This isn't balanced. Regardless of what we know, we have done this before, right? But regardless of what we knew, as long as we know the number of atoms has to be the same, you could look at this and say, well, I don't know what's wrong with it, but I know it's not balanced, right? Because 2 does not equal 3. Okay, so what we need to do is we need to be able to account for the fact that the same atoms that go in have to be the same atoms that come out. So if I look at what's going in, right now I have 1C going in, right, 1 carbon. And if I look over here, I still have that 1C, there's only 1 carbon coming out. So carbon's balanced, right? And if I look at sulfur, I have 1S here, but I have 2 S's here. So that must mean that 1C plus 1S cannot make 1CS2. But if I added another S, now I have 2 sulfurs. There's 2 sulfurs over here. 1C and 2 sulfurs makes 1CS2. Okay, so when we're thinking about that, that sounds like, oh, we're controlling it, we're moving things, whatever. No, in nature, like when your bike is rusting, right, that is iron plus oxygen in the air making iron oxide. So the Fe plus the O is making FeO2. Right? So that means it takes 2 molecules of oxygen that mix with that iron and your bike rusts. Okay? It's really important just to understand that what makes this cool is like the rocks that are, out on our playground right now are the same rocks that, had it been, 10 million years ago, are coming out of a volcano, right? All of these things, like we talked about how the carbon cycle, it's the same carbon that's been around since the dinosaurs. The nitrogen cycle is the same nitrogen that's been around since the dawn of time, right? The same thing goes for everything. All of these atoms that are here on Earth have been on Earth and will continue to be here on Earth, right? And that's not to say some things can't come and some things can't leave, right? Like we get hit by like an asteroid, or we get like little like space dust that comes down. Yeah, of course, little new things are joining us, but on the whole, like the oxygen that I'm breathing and the carbon dioxide that I'm breathing out, that's the same stuff that's been around forever. It's just being cycled and changed, but it's not getting new stuff and it's not losing stuff. Okay? When we take a look, you guys, tomorrow, I'm going to talk a lot more about this. But for you, when you're looking at your IB assessment for the chemical reaction that you're going to make a little presentation about, it's really important that we remember and that we keep in mind that I need us to be able to explain how do we know there was a chemical reaction, right? And then I need us to be able to explain and to demonstrate that the number of atoms didn't change. Because that's the important thing. This isn't magic, it's science, right? You're not just mixing stuff into a cauldron and then just magically making something on the other end. No, the atoms in whatever comes out the other end had to be present in those ingredients, right? So when I am watering a plant, right, and my plant grows, that is the water and the CO2 and the sunlight, and the plant is using that, reconstructing it, and making sugars with it, like we learned about in photosynthesis, right? It looks magic to see this plant just grow, but it's not. It's taking the atoms that were there and turning it into something else. And then I, in turn, could take that plant and eat it. My body could break that down. I could turn that into ATP. I could use that for energy. Those atoms are still there, right? The carbon that was in that plant is now in my body or is in my waste, whatever. So all of these things are still here. And that's really important with your guys' presentation. Okay? You're not going to actually be presenting, you're just turning it into me, so don't stress about that. But I'll have a lot more information on that tomorrow. Let me know if there's any questions. See ya.